Okay, so hi everyone. My name is Gwyn O'Sullivan, and today I'll be presenting on my paper, which is on the effects of an arm support exoskeleton on perceived work intensity and musculoskeletal discomfort, an 18-month field study in automotive assembly. And I know that kind of sounded like a lot, but this paper wasn't that technical, so I'm not actually going to get too much into the weeds of exoskeletons. Especially if you've been here before, you've probably heard some presentations get a bit more into the weeds. But the general background for most of these exoskeleton studies is that during work and labor, your muscles do a lot. And this can result in what's called musculoskeletal disease and disorders. And this is just not great because it can really impact your ability to move and just kind of exist without pain. So there's been this really large gap that wearable robotics has been hoping to fill with using exoskeletons to hopefully, to hopefully kind of support giving people their ability to do work without putting too much load on their joints and kind of hurting them. So that's like the general basis for a lot of these studies. This study in particular was actually based on a prior study that one of the authors did, specifically Marty Smets. He works for Ford. And he did a prior study where he kind of found that an earlier version of this exoskeleton, which is called the exovest, had some positive effects, but it wasn't really long enough to say anything. And he also found that they were smaller than kind of what you would see in a lab. So he was like, okay, maybe with these field exo studies, we should be able to generalize these lab results we're getting, but with smaller effects. So he just kind of wanted to look into this on a much larger scale, hence the 18-month timeline for this study. So why a field study? Well, field studies give way better information than lab studies about the realities of using exoskeletons in the field. So these are very important. And also, it was kind of interesting because this was a partnership between Ford Motor Company and then academic researchers, which was really cool to kind of see. Okay, so this ended up being a bit of a prospective cohort study. It was longitudinal and it followed the same group of people over the 18 months. It actually used 9 different automotive manufacturers. And while this was never really explicitly said in the study, I'm 80% sure they were all Ford manufacturers because that would make sense. And then they kind of sort of reference it, but they never say it explicitly. Next, this was kind of their demographics. It isn't listed in this table, but there was a mix of men and women. There was significantly more men, but it was nice to kind of see them taking in a variety of different workers. To start, they had 65 people in their exoskeleton group and 133 people in their controls group. A lot of the inclusion-exclusion criteria was based off the kind of work they were doing. You literally couldn't participate in the study if you weren't doing daily work on the overhead line. So every single worker in the study was doing work. You actually ended up being dropped from the study if you switched teams or you were just no longer doing overhead work. You were also allowed to withdraw if you just lost interest. The compensation for this study, which I thought was really funny, was a Bluetooth speaker, parentheses, $15 value. I thought that was really funny. But that was kind of their idea. But they did have, like I said, some withdrawals. They actually ended up excluding 2 of their 9 facilities. And this was because they kind of shut down for repairs. So there was just weeks of no data and them not using the exoskeleton. So they just threw them out. They were we're not going to pay attention to you. So in their final analysis, they had 41 people in their exo group and 83 people in their controls group. For the actual study itself, they had check-ins at 4 different month periods. So one at 1 month, one at 6 months, and one at 12 months, and one at 18 months. And at each of these check-ins, they would do 2 surveys. One was this one, which was the Cornell Musculoskeletal Discomfort Questionnaire, or the CMDQ. This was basically so that they could score musculoskeletal disease, MSD scores is what they called it. So they specifically looked at all the ones relating to the upper body, because that's where the exoskeleton was attached to. Next, they then asked them 2 questions, and these were based off of 2 statements from the cross-validated psychological climate and effort measures questionnaire. And unlike the Cornell questionnaire, I found 1 study about this, and it was locked behind a paywall. But so I don't know how valid it is. But they had two questions. When I work, I really exert myself to the fullest, and also I feel exhausted at the end of the shift. And they had everyone in their study rate these from like a score of 1 to 10. And that was kind of how they quantified work intensity. They also collected some data from video, where with the permission of the people working, they videoed them, and then they had ergonomic specialists come and look at the video recordings and analyze them with the Okra method. And this is just a way of looking at like repetitive actions and measuring like different factors for it. So they specifically looked at the posture factor, which is basically like the percent of time you're in a posture, and then the force factor, so how much force you're doing. And those were kind of all of the data points they were looking at. So what they did is they took their MSD scores across all of these months. And then if they did it on both sides, they only took the side with the higher scores. And then they also looked at the responses to those two questions about work intensity. They did actually do quite a bit in looking at like effect factors and whether facility, exo, and time were three factors that interacted with each other at all. They found that they didn't, which was kind of neat. But they did also use like facility subgroups to do everything, which was also nice. Now here's like the first kind of like part about the study, which is 40% of their data was missing. So how did they decide to solve this problem? They used this mice thing, which basically just generated data points that didn't necessarily follow the patterns. And this kind of gave them some estimates. Just to kind of visualize what that looked like, all the black is the missing data points. And that's for each month check-in. So there was quite a bit of missing data that they were filling, which I thought was kind of interesting. So anyways, onto the results. For work intensity, these were like all 7 of the facilities they looked like in one plot. I'll break it down a little bit better because those are way more interesting. But generally speaking, the exoskeletons were like allowing people to work more as time went on. And they didn't necessarily feel as exhausted, but none of these results are actually significant. So they were just kind of going, yeah, it kind of showed that. And then next, here are the musculoskeletal scores for each of the 4 areas they were really looking at. And generally, a lot of these trends show that the exoskeleton was less. They kind of pointed out the shoulder one where control kept going up and exo kind of just didn't. Another interesting thing was with the lower back, exoskeleton actually went above, which was kind of cool because you're wearing this device all the time. But like I said, none of these were significant. Next, they actually did look at individual facilities, which was where I think things started getting actually interesting. So they did show some notable differences. So like these 2 facilities showed like the exoskeleton actually decreased, like the intensity on people's necks. And it only really did that as time went on. So this kind of started to agree with previous studies about exoskeletons working better after you use them more. Next, they also looked at shoulder. This one was really cool because at first it was way higher and then it like dipped down after the months and they got used to working with the exoskeletons. And they did observe really large confidence intervals for all of these scores, which then showed that it kind of like varied across workers, which was another thing that people kind of already knew, but it was nice to kind of have that backed up here. For wrist, which is like neat because the exoskeleton really only supports you at the arm cuffs, it did remain really consistent for 2 of these facilities. They had their wrist scores just like stay consistent, even as the control group's wrist scores went up, which they were kind of pointing out was pretty like different. And then these are the responses for the work intensity questions. And only one of the facility actually reported any changes in their working patterns within the exoskeleton groups. All the other ones are pretty much just flat lines. So some conclusions they came to, there were really no significant longitudinal effects on this perceived physical demand, which are those 2 questions about work intensity. Next, using an exoskeleton may influence the patterns of how people are doing their job, which is kind of what they were talking about in that one facility showing people looking at work intensity going down. And then they also kind of owned up to it. And they were like, yeah, I think future studies should be a bit more systematic and have more evidence as opposed to just like the qualitative data they showed here based off of surveys. So there were a couple of strengths to this study. One, it was in an occupational setting. This was taking place exclusively within automotive manufacturers. Next, it was a very long-term study. Like this was over a year, it was 18 months, and it had a much larger population than a lot of the previous studies I've looked at. And then the exo and control groups were actually really similar, which is really nice for a study. They were both doing the same overhead work and they were both completing the same shifts. And then they had ergonomic specialists running all of their data and analysis, so they did know what they were doing. And then they were super detailed on the methods. Like it's like pages of the methods if you look through the actual paper itself. And then they acknowledge their limitations. They have a whole segment at the end where they talk about all the things that kind of like they could have done better or that they were very limited with, which I really appreciated. Onto the weaknesses, they didn't look at any quantitative measurements. Like they didn't take any EMGs. They didn't have a doctor come in and actually like look at any of these people. It was all based off of how the workers felt. And then the Okra scores, which is like what they were doing with the video, they didn't really report them, mostly because they don't actually represent any physical magnitudes of these demands because they only used a subset of factors. So they were just using it for relative comparisons. So I think they probably could have been a little bit better with that. And then they didn't prescribe a set amount of time to use the exoskeleton. They kind of snuck this one in at the end. They just kind of told them to use the exoskeleton when they wanted to use it. And then they did have something to track and monitor how long they were using it, except that proved to be really unreliable. So they don't know how long these people were using the exoskeleton for. And then finally, this is how I know that they were all Ford automotive manufacturers, but they said that Ford actually limits the amount of time that people can do overhead work, which is already really great for overhead work. But if you're studying how an exoskeleton helps people do overhead work, it's not great because there's already these ergonomic things in place. And then the workstations themselves had already been super ergonomically optimized as a part of like Ford's initiative to help with this. So they were saying, at least in the study, that this probably could be done at an automotive manufacturer or like construction or something with way less of these ergonomic things in place. And then before we get into the questions, I pressed my button. I asked ChatGPT to give me some similar articles for my AI component, and this was kind of fun. I said, hey, give me articles similar to, and then I put the name of my study. So 4 of them are real. The first one is actually my study. So maybe I wasn't specific enough. The next fun part is all 3 of these links link back to my study. Now I hear you. You're like, what are the other 2 links? This one links back to number 2.
Okay.
And then you're like, okay, you said 5 wasn't real, so what's the 5th link? The 5th link is actually for this study, which if you'll notice, actually is a really similar name to this study, except instead of saying it's on perceived exertion during overhead work, it's suddenly about doing field tasks. Although I did actually open the study and look at it, and it does seem to be doing overhead work. So I don't think it was ChatGPT was like wrong, but it's not the same study that they told me. So there you go. When ChatGPT tells you that it may be wrong, I would check it because it was not correct here. I did also like hitting on its like sources pop out that it had, and it was just the 2 links. And then this one, it was funny. I was like, okay. Anyways, so that's the end. Here's my discussion questions that I came up with. Like I mostly wanted to talk kind of about like the large gaps in their data because I thought that was really interesting, and they just kind of like randomly generated data points. And I was like, how would you address these large gaps? Yeah.
I just have a question. So you said that they filled the empty data with random data?
Yep.
What do you think that, like, how does that affect the...
Well, it was really weird because they were like, yeah, we didn't want to use like patterns to do it. So they kind of like, when they talk about it in their missing data section, they were just like, yeah, the estimates can be biased when data are missing and not at random. And they just kind of like I got really lost when they were talking about it. I'm not good at stats. There were some of those, if you remember the figure with all of that, I think they just should have thrown out the ones where they were just missing all of the data for that month because it feels a little disingenuous. Yeah.
So, not saying it's a good decision, but
Yeah.
part of the reason why they probably did that is because they were using all these kind of fixed effects in their regression models, which they didn't get any results from anyway, but
Yeah.
setting that aside. And those models don't generally do very well with missing data. It can be really hard to estimate them. So they probably just filled it in because their N wasn't that big for that method anyway.
Yeah.
Especially when they're piling on all these fixed effects. So like I would definitely not have the takeaway of this being that as evidence that there's no longitudinal effect, but just like given the type of analysis with their N, it would be really difficult to show anything, especially with the missing data.
Kind of missing at random data. Most studies have missing data, and most studies don't tell you what they did, how they fixed the problem. Planet Mari, I know a guy, he's very careful. We've alluded to that. Very particular. He's actually telling you what he did, which is very thoughtful. The big problem is, you know, if it's all missing at random, then it's pretty easy to impute stuff and fill in the blanks. Okay, that's totally acceptable. The big problem is when things are not at all missing at random, you know, the example for us was rolling people, and the people refused to be weighed were all 350 plus club. And, you know, the statistician said, oh, just impute something at random. They're like, dude, you can't do that. And we use just a combination estimates of estimate of weight. There's just a way to get around that, but that's how you have to really think about data, why are they missing?
Okay.
So I'm going beyond your talk because the question came up. And
No, that was like I
everybody's
was
got a
confused
deal.
on, so I'm glad you like talked about that. But I agree with you. I thought like the way they did their methods was super thorough. Like they went into like every little detail about what they did, and I thought that was really great. Like it was
Very nice detailed guy.
yeah, it was a nice paper to read. It was really easy.
Yeah, exactly. That's also a classic of them. So we did studies with Ford 26 years ago to 27 years ago with overhead work. And at that time, of course, people were saying, why don't you just automate it? And it's like, I mentioned this because it's 27 years later. What was their change that they implemented? You mentioned it. Limit time, limit exposure. That's what their intervention was. And this study is heavily addressing the shoulder. Was there a difference between the exoskeleton and the non-exoskeleton?
They didn't find any like significant difference. But there was some.
Like shoulder. I'm just speaking of shoulder.
Yeah. Yeah, there we go. At the shoulder, that was the big one that they did point out, where for the control group, it did go up. Like it kind of steadily went up, but across all, like when they combined all of the different manufacturers, the EXO actually started leveling out after time, which was kind of cool.
So you got some suggested modest differences in the neck and the wrist, not the shoulder, which was the target joint.
Well, this is the shoulder, so there is like suggested differences.
Neck are different, but the shoulder is nearly identical.
Yeah. And then their shoulder. This is out of the appendices.
Right.
They broke everything down. And I thought this was the more interesting one, like to look at than the like combined graph. Because you can kind of see in like a lot of these ones, like this one is almost flat, this one is almost flat. Whereas like this one has like so many jagged and this one actually spikes too before being flat. But what they were pointing out is like this one facility showed like this marketed decrease over time where it started out obviously putting like, I guess, a lot of weight on the shoulders, or that's how they perceived it. But then it became like their scores went down as time went on, which I thought was kind of neat. But overall, none of the joints were showing any significance.
They speak at all about any fundamental differences between the different sites? Like, I wonder for the sites that were maybe flat or the ones that have this large variability, if there's some difference in either the equipment they have or the manufacturing setup that may have contributed to this?
I don't remember them mentioning that. No. They might have. I might have skipped over that, but like when they talked about it, they just kind of talked about how they had just these 9 automotive manufacturers. And that was kind of like all they said. But they did say that like Ford itself, which like I said, I think is the overarching company for all these manufacturers, had all these like ergonomic limitations that they already implemented for their factories.
Do you think it was useful that they chose these 7 different sites or 8 different sites? Or do you think it would have been more interesting if they had looked at each site more individually in terms of their analysis?
I like that they looked at all of them just because they were the same like manufacturer, and I think that really kind of speaks to it. In terms of it being interesting, I thought when they started breaking it down by site, that's where it became more interesting. Because like they sort of started talking about like how it was really interesting and weird that like L3 had these 2 changes in like perceived work intensity where the other sites did not. Like they just kind of flatlined. And I kind of was like, oh, well, what was different about L3? But they didn't really get into that. So I think if they'd spoken more, it would have been kind of neat. But I don't know if that's just because it was too much information. Yeah.
I think one way they could have maybe grouped this data is based on like the small, medium, or large vehicles that are being manufactured, right? Because that's what the S, M, and L are here. And I think that that maybe would give a better idea overall, except that still L3 is kind of the only one you're seeing a difference, and then it might end up skewing kind of this large vehicle manufacturing apart from the small and medium. And
yeah.
I could see some of this data being maybe it's not so much whether it's a small, medium, or large vehicle you're working on, but it's more about maybe what does your shift breakup look like? Like if you're limiting time, are you doing all 4 hours that you're allowed to do overhead work right away? Or is it like broken up half and half? Maybe those other, maybe more procedural policies could have played a role
Yeah. And
more greatly in L3 as opposed to.
I think it goes with that. And then the amount of time they were using it, because they kind of speak in the study about how they didn't tell the EXO group when to use it. So they were saying that there might have been people who only started using it when they started feeling sore or like they were going and like they were doing too much. Where there were maybe some people that just used it the whole time and they really have like no like consistent way of telling that, which is why they didn't really report it. Yeah.
You know, if the subjects were trained on how to put it on and how to use it, and did that training only happen at the beginning?
No, they didn't talk about it. Yeah. They did let them keep the exoskeleton after it was over, but yeah, it was like a voluntary. Yeah, they don't say. Yeah.
What is the rationale for like the participants were recruited in a 1-to-2 ratio for their EXO and control group? Like, why did they choose to have a control group that was twice as big?
I don't know. I guess I don't know. I don't know enough about statistics. I'm not good at statistics.
Epidemiologically, you often times like to have that kind of ratio, 2 controls to 1 intervention or case. And part of the reasons try to prevent some of the confounders and stuff like that from the outcome, end up with more stability in the controls.
Yeah.
This is just a comment about measurement of psychological experiences like work intensity. it's a problem in psychology. I don't know how common this psychological climate and effort measure is in engineering, but you can make a huge difference in the quality of a survey scale by having it anchored in specific criteria. So strongly agree to strongly disagree, I really exert myself. If you anchor it against an activity that every single participant, like, this is really exerting, this is like doing exercise that makes me breathe so hard I can't carry on a conversation. And it's just really surprising to me that big expensive studies use measures that are just totally individual perceptions with their own, who knows what their criterion was. And then the other feature is physical fitness levels. So, you know, something might be truly vigorous intensity physical activity for somebody who's low fitness, causing them to breathe hard, increase their heart rate, and so on. But yeah, so I guess more comments than anything about if you have an opportunity in your thesis or dissertation research to use criteria that anchor a rating, you know, what does a 10 mean versus a 0, it really substantially improves the quality of measurement.
Now, it's interesting you say that because when I was like doing stuff for my undergrad, I was always being told, hey, if you give someone a number, like give them a physical thing behind it. So instead of being like, oh, this weighs like 10 pounds or something, be like, oh, you know, it's like the weight of a backpack on someone's back. And I've always thought about that. Or like, it's this big, which is the size of this.
Yeah, it's a form of psychological calibration. You know, if there's no calibration for what a 10 means,
Yeah, what's a 10?
Everybody has their own personal anchor that they're not sharing with you.
The outcome.
The outcome? So I don't think they implemented exoskeletons like across the
I'm
board.
sorry, I'm sorry, my mayor.
You're good.
What is in this study, you have an intervention, you have an outcome. What is their outcome measure?
Okay, their outcome measures were the MSD scores, so the musculoskeletal scores, and whether or not it like lowered them or raised them.
Right, the disorder.
Hmm?
The disorder.
I don't think it's a disorder. I thought it was really interesting that they called them MSD scores because really the like questionnaire sheet was asking about like the state of them, and it wasn't really like I said, I thought it was really weird that they called it that, but
This is again Maury. I like him, he's a friend. But Maury will call him MSDs. It's like, that's not MSD, Maury. You gotta, you know,
yeah.
these are symptoms. It's not a disorder. You go to the doctor. You know. Anyway, you have to then have the leap of the point is you have to have the leap of faith that these symptoms relate somehow to actual prevention of disease.
Yeah.
The scale is a D, but it's discomfort, not disorder.
Oh, it's not.
Yeah, the Cornell musculoskeletal discomfort.
Okay, so that's on me. I read the D, and it's always MSD, and these
Right,
other
but they
ones.
put MSD in the graph, and MSD, everybody in the field thinks disorder. Like,
No, I think I straight up read it, and I was like, oh, it's discomfort, and then I saw the graphs, and I'm like, disease. Okay, thank you. Sorry.
They also use disorder in this thing too, so it's like.
We love acronyms. Always fun.
EMG, you mentioned EMG. Running out of time, but you're talking about surface EMG.
Mhm.
And you mentioned they could have done that. You want to talk a little bit more about that, or I don't know?
I don't know how like feasible it would be to implement it in like a large scale 18-month study in a like an actual factory where they're doing stuff. It's just kind of like if you're doing it stuff in a lab setting, you normally use EMG, which is electromyography, which basically measures muscle activation. So you can see how much effort your muscles are putting into tasks. So when you stick EMGs on someone who's using an exoskeleton, you can see if the muscles themselves you're using them as much as you would without the exoskeleton. And that's kind of just a more like quantitative way of saying, hey, look at what the exo's doing and how your body's reacting to it. Yeah.
So if you were to implement EMGs, how do you think you'd have to change the protocol, or how would you compare some of the results?
So I think they would have had to either change like their timeline and they would have had to be way more involved, or what they made like the way I would have done it, like not having ever run an EMG study for exoskeletons, is at the different month marks where they were checking in with people, I probably would have ran a different like EMG test. And at this point, the exo group has hypothetically used the exoskeleton enough that they know how to use it, so you don't necessarily have to train them every single time. And you can come in, put the EMGs on them for a shift, and then you could compare that across all the different subjects. But they did have a lot of subjects.
Main use is going to be, I think, pre-post, basically.
Yeah.
You have a baseline, you don't move the surface pad, and then you put the device on.
Yes.
Not gonna be longitudinal to do this.
No.
Because of the problem, so it's very hard to locate. The other problem you have with the posture that people use to lift overhead is going to vary markedly.
Yeah.
Because some people will, for lack of a better term, they'll lift straight in front of them like this. Others are lifting out to the side like this. Markedly to reduce their shoulder for the same task.
Oh yeah.
Yeah, so in the real world, you can't control it. In the lab, you control it, but then what application does it have to real world?
Yeah, and I thought it was cool that they were using the video. I kind of wanted them to talk more about it because that's where they were talking about like the different postures everyone was using. And they didn't end up reporting on like how these posture factors changed. But I thought that it's like you said, everyone does it differently. It is also a problem in like lab settings, especially when you're doing like squatting tasks. Like everyone squats and lifts differently. And there's really not much you can do about it.
You can control it, but then it's applicability.
Yeah, exactly.
Anything else on this one, guys? Cool.
Oh, thank you. Like, I have a waterfall.
You had one that used.
One that everyone's used.
That's rock and roll whenever you want.
Yeah.
Right. I'm gonna get going now, but hi everyone, I'm Jesse Prime. I'm also in the HEN lab for bionic engineering, so I am also going to be presenting on another exoskeleton study. This one is a laboratory setting study titled The Biomechanical Evaluation of Passive Back Support Exoskeletons in a Precision Manual Assembly Task. Expected effects on trunk muscle activity, perceived exertion, and task performance. For some of my AI, I just got some extra photos off of ChatGPT because I think it's fun. I still do want to point out that there's always like horrible text in these computer-generated images. It spelled everything wrong, and on the bottom it gets illegible. But yeah, I do find that really enjoyable. However, I do actually have, wrong button. I actually have a kind of detailed section on some AI that I use to do a literature review and where I found this paper. So for those of you who don't know, there's actually a relatively new artificial intelligence called Undermine. It's supposed to be a research tool for students and professors that kind of does a literature review for you and provides a long list of papers and detailed background and all sorts of useful information for starting your research review, I guess. So it's called Undermine. I kind of went through some of this. This is just a little snippet off of their website. And kind of how it works is it's similar to ChatGPT. So you have this chat window and you're going to type in a question. My question is right here. I asked for some research on both passive and powered exoskeletons, specifically relating to lower back support. That's kind of what I'm working on in my research. And it asks some follow-up questions. And what you get out of this is a super long list of papers It gives you key findings in all sorts of metrics. It gives you ratings for how well it thinks it relates to your research, these green numbers, citations per year, and all sorts of stuff like that. And that's kind of where I got my paper from. That's right there. I do think it's actually a very handy tool. So if you're giving any sort of literature review, I would really recommend trying it. Anyways, so getting into my study. Right now, occupational exoskeletons are kind of in an interesting place. There's lots of technology running around for new devices, and there's a couple of devices that are on the market right now. They kind of operate in this niche zone. So we talked about this in Gwen's presentation, but you end up with these physically demanding tasks, and a lot of people will be like, you should automate it. So I keep clicking down. Right, we have this car manufacturing plant, right, what Gwen was talking about, where a robot's putting the entire car together instead of people. This really only works in specific situations where you have some task that happens repetitively all the time that you can make a robot do. It's not complex enough that the robot can't do it. And it also has to be worth it for the company to, invest super heavily in these super large robots. They're very expensive. They're kind of dangerous. It's a whole big deal. On the other hand, you have preventative measures you can provide to your workers, and oftentimes there are much simpler options like mechanical lifts for moving engines around and nicer workstations and trainings. But there's also these tasks where you're doing super complex movements all over the place in your job, and in that case, sometimes it's really useful to have exoskeletons. So the main goal of this paper was to evaluate two commercially available back exoskeletons, passive devices. So that means there's no electric motor, there's no batteries. These are just like springs and pistons, that kind of thing, carefully placed on your body to provide support to your lower back. They were very curious in improvements to the user's health. So as a proxy for this, they did EMG measurements, improvements to the worker's productivity and performance. So they were measuring time to complete a task in this case, but they're really curious about how these devices affect workers' ability to do their job, and improvements to exoskeleton capabilities. So devices are generally very specific, and they work very well for a small subset of tasks. In this case, these devices work very well for supporting your back when you're stooping over. So that's kind of their logic behind the study. For their methods, what they did is they collected 18 total volunteers, 9 women and 9 men with no musculoskeletal disorders in the past 12 months. They were all grad students, I'm guessing, just from what they said in the paper, and the average age, which I think I'll mention later, but I always find that kind of bad for these studies. What they had each subject do is they did this simulated precision assembly task where the participants picked up pegs and placed them in a pegboard as quickly as they could. For each of these tasks, there were 26 conditions, so you have a variety of different heights you're operating at and different orientations you're turning your back. There were also unsupported and supported conditions. So in the unsupported condition, you had no chair, so you're standing or on your knees and bending over. In the supported condition, you had a chair and you were stooping over like a small table or below your ankles on the floor. The exoskeletons that they evaluated were the Laevo and the BackX, which are from 2 prominently well-known exoskeleton companies. Some of these I don't think are available anymore. The BackX has been replaced with a new model by Sudex, and I'm not sure about the Laevo, but they are still running around some places. So on the first day of experimenting, what they had everyone do is they had the participants get fitted to the exoskeletons as per the manufacturer's instructions. These devices also have personal adjustability, so how much assistance you're going to get and kind of where they start working. I thought this was interesting, but they just had the participants choose whichever assistance level felt best for them. So there was not a lot of consistency, I guess is what I would say, among participants, but they were controlling against themselves. So On the second day, each participant completed each assembly task with each intervention. The order in which they're doing these interventions is randomized. So some people started with one exoskeleton and then did the control and then did the other exoskeleton and all these combinations. They also used Latin squares to determine the order of the height at which they were doing the intervention. So like knee height and then ankle height and everything in between. What they did have everyone do is complete each intervention completely before moving on to the next one. So if they had one exoskeleton, they did every single task and every single combination before they moved on to the next exoskeleton or the control condition. During this, they collected EMG data on a handful of muscles. They did the rectus abdominis, the external oblique, and I have such a hard time pronouncing this, the iliocostalis laborum, and the thoracic erector spinae. They also collected the time to complete each task with a stopwatch. So what we saw from this was a handful of things. They saw significant changes in all of their their EMG measurements for intervention, task condition, and gender. They also saw significant changes for intervention across task condition and gender for the EMG data. And for intervention across gender, they also saw significant changes in task completion time and rated perceived exertion for the unsupported condition. And I definitely forgot to mention, but they also collected rated perceived effort for each subject based on the Borg CR10 scale. Let's see. Oh my gosh. Come on. Sorry. So these plots, or sorry, these figures kind of show the relative change in median EMG signals over each activity and each posture, so each task condition. I thought this figure was kind of interesting, primarily because there's lots of data that's just missing, and they never, from what I saw in the paper, mentioned why these measurements are missing. I thought that was kind of interesting. There's also a couple of things that I thought were interesting relative to each exoskeleton. So the back X, you see these green boxes, which mean there's a reduction in EMG activation at a lot of these positions. When you get lower down, you see these red colors where you're seeing increases in EMG signals. For the LiEVO, there's tons of missing data again, and you're seeing your best results at this knee level, and you're seeing pretty extreme increases at the below floor level. So I thought that was just kind of interesting that a lot of the data is missing, and also that in some cases for some of these exoskeletons, you're actually seeing much worse EMG activation. For the rate of perceived effort and the time to complete task, we see there's some kind of interesting results. So for the time to complete each task among the females, we actually see a significant increase in time for both exoskeletons. For the men, or for the males, there's no relative change among all three tasks. And for the rated perceived effort, there's no trends for the females. And for the males with the back X, there's actually a significant increase in the rated perceived exertion. And there's kind of also this trend with the exoskeletons with the males with increased rated perceived effort. The score overall is pretty low, so no one saw a ton of effort or perceived ton of effort using these exoskeletons, but I thought it was interesting that people found it harder to do tasks with these devices that are supposed to help you do things. Yeah, so it's kind of a lot of what we talked about again. More ChatGPT images, which I always like. Using either back support exoskeleton saw significant decreases in a majority of tasks at all heights, except for the LiEVO at the floor level. The significance of intervention across tasks kind of suggests that these exoskeletons are pretty well designed for a variety, or not a variety, a very specific subset of tasks. So it's kind of important that you're choosing these devices to do a very specific thing that they're designed for. In general, we saw larger EMG reductions for the back X than for the LiVo, which I think is kind of interesting. I think these are very similar devices, but one seems to be working a lot better than the other. And the best EMG reductions tended to occur in the most symmetrical tasks. So if you remember when they were doing this assembly task, some of the tasks, the pegboard was right in front of them, and some of the tasks, it was 45 degrees to the right and 90 degrees to the right. So the more asymmetrically you're doing this, the worse EMG reduction you saw, which I think is pretty par for the course as far as I'm aware. So as far as strengths and weaknesses, I thought it was kind of nice that they had a large number of task conditions that they were completing this in. So I think that kind of mimics the wide variety of tasks you'd see in a real workplace where you're working at different heights on different things. I think that's pretty realistic to the real world. I think it was also nice that they tested on commercially available exoskeletons, so things that people might actually be using right now. I think some of these how hard it needed or how hard and we recruit heavily from our own, which is very much not represented in the population. And I think runs into a lot of issues where you have well for unfit people and not very well for people who actually need it. The EMD models mentioned in the paper also chosen based on some previous research, but also what was convenient for them to measure with the exoskeleton on. So I think it was kind of interesting that they chose a bunch of muscles that kind of benefited how easy the study was for them and not necessarily what they thought was best for measuring. They also didn't analyze each EMD separately. They kind of combined them into these measurements. So they had, I forgot what they called it. I think like TEM left and TEM right, which is total erector muscles on the left and on the right, and then PTM, which was total trunk muscle activity for like the entire body, so bilaterally. I thought that was kind of an interesting way to do EMG results. I don't know too much about that kind of work, but it seemed kind of interesting to me. Yeah, and then for questions, I guess I had a couple of things I thought were interesting. So I thought it was interesting that the EMG results are reducing effort to complete most of the tasks, but perceived exertion for both males and females is either unchanged or significantly increasing. And I was curious what everyone thought this might mean for the adoption of exoskeletons in real life workplaces. And there might be like long-term compliance issues with these devices, which I guess we kind of saw in Gwyn's study where people are dropping out. Yeah.
I feel like if you're a young person with a completely working body, it makes sense that if you put like a frame on them that restricts their movement, especially for like a short period of, it's not like a super prolonged task. It makes a ton of sense that they would rate their perceived exertion or effort as higher, just because it probably is easier to do it without a device if your body's all good.
Yeah.
Versus like someone who's actually working, they're older.
Yeah, I think that's like a valid point. Some of what we do see with the devices in our lab, right, is that people really hate it when you have to like push into these springs and use more effort to get to some position. So I wonder if some of this is also coming from that. I know that the back X works similar to what we have in lab right now from Sudex, where you have to like push into this spring that's at your waist to get down to the stooping position, which is like a really unnatural feeling to like have to fight a downwards movement.
I had another question about the EMGs. So they picked two like trunk flexors and two trunk extensors. How did they combine them in that plot with all of like the increases and decreases? Because especially for like the ones where you're really bent down, it would make sense that the trunk flexors would be more activated, but I would expect the extensors to be less activated.
Yeah, so before the study, they did maximum voluntary and isometric contractions. So they're normalizing based on each user's initial contraction, which I think is the standard, if I remember right. And then for the trunk extensor sorry, TEM, LNR, they're taking the median value for the task of two separate muscles, if I remember correctly, and averaging them. And I cannot remember. What?
Did you look that up?
I think they did. I think it's their own unique measurements.
That's standard.
And then the total trunk muscle activity was the like average of all the muscles or the sum of all the muscles, I think.
You know what was shown on the stop?
Sorry, you know what was shown?
On the
Oh, on the figures. I think it is relative increase or decrease of the total trunk muscle activity.
showing all three groups. Never mind. Okay.
Yeah.
Thank you.
What do you think of did you see the amount of time to complete these tasks, the amount of time between the tasks?
So the amount of time to complete the task, I think, was in the range of 10 seconds, if I remember correctly, which I thought was a relatively short time for these like static pose tasks. I think it's pretty unrealistic that anything a worker is going to be doing consistently is going to be like a 10-second task before they're done. So I think for like these long-term tasks where you're stooped over like a car, for example, I think it would be more realistic that you're doing that for like 5 minutes or 10 minutes at a time, maybe, depending on what you're doing. So I thought that was kind of unrealistic to the real world. They also had 1 minute rests in between each task and 3-minute rests in between each intervention. Depending on how exerting this is, and given the rate of perceived exertion, I think that's pretty low. I think that might be a reasonable break in between each task, but I think there's a chance that as you get to the latter interventions, your muscles are performing differently.
I was going with the fatigue question.
Yeah.
The counter to that is the RPE.
Yeah.
The RPE is one.
Yeah.
Unassociated with hazard.
I would guess not.
Yep. Right.
They also changed the order in which you were doing interventions, which
That was the description of that was odd though. I mean, you'd really want them totally randomized and sort of, it didn't kind of, it almost sounded like they were doing a bunch of random things in one position, not randomizing the entirety of the
yeah,
board.
I think, yeah. So from my understanding, I had to look up what Latin squares were. So you have like these three combinations of interventions. You have no exoskeleton and the other two. And my understanding was that each subject had like a random order in which they did these interventions. I think that's what that means, although I'm not 100% sure. And then you are correct, at each height, they were doing the tasks in a random order, but that was the only thing they said was fully randomized.
And gets back into the concerns about
Yeah, fatigue.
exactly and getting different results with different order where there was some accumulation.
Yeah. So there's no mention of that, which is not a great sign. But for what they're doing, I think it was like a relatively good study, although I think there's definitely some room for improvement. Also, like all the missing EMG numbers on those figures really bugged me that they said nothing about that. Nothing I could find. Yeah, I guess there were some other questions I had for discussion since we still have 5 minutes, but I thought it was kind of interesting that they were, oh yeah.
I'll throw one out, probably more of a comment than anything, but so, and probably less in your study versus the first one, because very much looks like yours is, students and young and fit. And so in the first one where it's workers, my experience tells me when you try to introduce something in the workplace, even though it's going to help people from a health or safety perspective, they're very resistant.
Oh yeah.
They don't want to wear something new. They don't, and kind of the earlier comment about just the perception about wearing the device and how it gets measured. But, that's kind of what I was thinking about the whole time is particularly, with these two, you're introducing something on people. And generally there is a reluctance for people to wear things like this. Did either one of those studies address the kind of the bias, psychological bias that might go with that?
I don't think either study really did, but I can comment on some of this. Like we at the University of Utah work with a couple of companies that do this sort of work. And what we've heard from them is actually that like it takes very little for these workers, even if they like the device, like it'll take one comment from a friend or a boss saying that like it looks weird or it looks funny that they're wearing that, and they'll actually stop using it. So I think it's a very valid concern that these devices are just like not going to be very well adopted. And I think
in Canada, we introduced a safety device that would save lives
Mhm.
and ended up in a work walkout.
Yeah.
You know, when you introduce it, anyway, I just throw it out because I'm thinking of that whole thing, you know, how it's perceived in the workplace, right?
Yeah. Margaret.
I used to work for a startup that was trying to make exoskeletons for the DoD, and one thing we often talked about was not only is it like maybe it's like as Bree said, frustrating to wear these things because like your range of motion might be different, you have to move differently, but that also adds a mental load to doing the task. And so now your task, which is maybe very easy for you to do, you have to think 20% more about, and then that kind of adds a little of frustration, which I imagine is probably also somehow reflected in these like perceived exertions or like how easy the task is. Because like now it's harder because I have to think harder, which is oftentimes something we don't think about. And I think something the field could do a better job of designing for ease of use rather than like maximum benefit.
Yeah. We also see like learning effects too, right? Where like maybe at the beginning when you're first using these new devices, they're new, so you don't know exactly how to work with them super well and you're not used to it. So oftentimes in these studies, we see better results as time continues on. So you learn how to use the device and you get used to it and it helps you more. So overcoming some hurdle like that where you have to really get people using it at the beginning and then maybe they get used to it and they like it and then they start using it a lot. But it's hard to say.
That would just suggest best practice would be a habituation or a adaptation period and experiments. Let people use something until they are comfortable with it.
There was a 3-hour learning period for the device in this study, but I think Grace might have a better insight into this, but I don't think the learning period is 3 hours enough to learn
That's enough for able-bodied.
for able-bodied. Okay.
I don't think there's great research.
It could depend on the task. For walking, that's more than enough time.
Yeah. So like this 3-hour learning period may or may not have been enough for them to really familiarize themselves with a new device.
And to the point of mechanical advantage, that's so beneficial, then nobody will care that the weight of the chainsaw is much more than the handsaw.
Yeah.
What I'm saying is when we will get, I think, to that point where the devices are less clunky that way.
I hope so.
And the whole math will go upside down.
Yeah. I do think we're like a long way off from that, just from like what we're doing in our labs. We have these devices that are fully capable of supporting like your entire knee joint going upstairs and stuff like that. And they just do not feel perfect yet. It's so many small things working together and it's hard to make it feel like it's just your knee doing the work. Yeah.
Anything else for Jesse?
I will say what the times I've worn exoskeletons, I didn't realize while I was wearing them what they were doing. It was really only once I'd taken them off and I tried doing the exact same thing that I'd been doing that I was like, oh,
yeah,
I see. So I think there's like that element in like perception too.
Yeah, it definitely is like a whole perception thing where like you're wearing it and it feels normal and then you take it off and wow, it's actually much harder to do this again. And I see that a lot with some of the devices in our lab. Like I have an ankle exoskeleton and we walk with that and it does all the work for my ankle and I take it off and I'm like, this feels weird. I have to actually move my ankle again.